Hi Pre-Calc. Today we're going to work on 1.6 and 1.7, which focuses on graphing. I'm going to start with the greatest integer function, and if you notice that these are double brackets here, so it's two brackets on each side. The greatest integer function is also called the step function. And what's important about this function is that it always rounds down. It's not like how we sometimes do chemistry and physics, where if it's a 5 we round up, if it's less than 5 we round down. It's not like that. It always rounds down. That's all it does. If it doesn't make it to the next integer, it rounds down. Okay? So let me just do a couple with you to make sure you understand the concept, and then we'll worry about drawing it. So if you put an integer into this function, it will output that integer. If you put something that has a decimal, it will always round it down. So 3.1 will round down to 3. 3.99999, I did this to be obnoxious to make sure you're understanding the concept. It does not care. It will round down to the nearest integer. That's all it knows how to do. So since this didn't go to 4, it's going to round down back to 3. Okay, so make sure you understand that. Now negatives, if you put in a negative, same idea. This is -4. It's an integer. So integer in gives an integer out. Now when you're doing the negatives, just be careful. We tend to get a little confused. -4 sits in between, -4.1 sits in between -4 and -5. So if you say the answer is -4, you've actually rounded up. Okay, make sure you round down. You have to go to the left to round down. So this equals -5. So this number here, -5, is smaller than -4.1. All right, so negatives are just a little tricky. Be careful. All right, now let's draw it. Let's draw the greatest integer function, also known as the step function. So if you pick any x value in between 0 up to 1, any x value from 0 to 1. So think of it. If I put in here, in this function, 0.5, it's going to round down to 0. 0.75, it's going to round down to 0. 0.9, it's going to round down to 0. But the minute I get to 1, and I put in a 1 in this function outputs a 1. So that's where it jumps. It jumps at the integer. If I put in 1.2, it outputs a 1. If I put in 1.5, it outputs a 1. If I put in 1.9, it outputs a 1. It's not until my x value goes to a 2 that it jumps to a 2. Okay? If I put in a 2.1, the output's a 2. If I put in a 2.5, the output's a 2, and so on, up until I get to 3, and then it makes the jump again. So on the test and the final exam, I just want to make sure you give me at least 3 steps. Okay? Sometimes students ask me, like, how many steps am I supposed to draw? So you make sure you draw at least 3, okay? And then it's just this repeating pattern of these steps. All right, so this function looks like stairs because it's flattening the y value, because all the heights get flattened down to a particular integer. All right, just real brief, we are going to graph today, but just real brief, I want to go over what we would call parent functions. If you look in your book, this is on page 64. Parent functions are standard shapes that we manipulate. Parent functions are like standard shapes that we manipulate. So here's your constant function. They're specifically giving you the identity function, but this is just an example. These both are examples of linear functions. You've got your absolute value. It looks like a V. You've got your square root function. Some people say this looks like a hook. You've got your squaring function. We also call this a parabola or a quadratic. You've got your cube function. You've got your reciprocal function. And the one we just drew was the greatest integer function. Okay? So we're going to be manipulating these parent functions today. I'm going to stop this intro video here and pick up on another one very shortly. Catch you soon. Bye-bye.